Okay, so this is for Mrs. Cucci's College Now Pre-Calculus class. We left off on lesson 3.5. We had just finished horizontal asymptotes. So now we're going to pick up on oblique asymptotes, otherwise known as slant asymptotes. So please open up to page 1.25 and we can get started. Okay, so sometimes we wind up having these asymptotes that are slanted, okay? They're not always going to be vertical or horizontal, so there are other things that we need to find. The way that we can determine if there's a slant asymptote is by looking at those degrees. If the degree in the numerator is greater than the degree in the denominator, you're going to have yourself a slant asymptote, and you have to know how to find that, okay? So now just by looking at this, at the denominator, we know that we have a vertical asymptote at x equals 2. Okay, so that was pretty easy to pick up just from what we already knew. So what we're going to do to find the slant asymptote is we're going to use some long division. Okay? So here's my function. To find the slant asymptote, what we're going to do is we are going to divide the denominator into the numerator. Okay? And we learned how to do long division a couple lessons back. Okay. So first thing I need to ask myself is, what do I need to multiply x by to get 2x squared? And that's going to be 2x. We distribute that back through. And then we have to remember to subtract, right? So this becomes minus plus. So this becomes positive 1x, and I'm going to bring down that minus 1. What do I have to multiply x by to get x? That's going to be a 1. Distribute that back through. X minus 2. And of course, subtract. Minus plus. And we get 1. Okay? So what this winds up being is 2x plus 1 plus 1 over x minus 2. Okay, it goes over your divisor. Okay, so what we have here is we have a slant asymptote at y equals 2x plus 1. Now we wind up with a slant asymptote. And as we said before, just by looking at this, we also have a vertical at x equals 2. So we have two asymptotes there. Okay? So, if I wanted to, just to take a peek at this, we've got our asymptotes at x equals 2. And 2x plus 1, so we know the y-intercept's at 1. Oops, sorry about that. A little overzealous there. Oh, that's not what I wanted. That's okay. At 1 with a slope of 2. So up 2 over 1, up 2 over 1, up 2 over 1, Okay, so we're going to have another asymptote that looks like this, although not perfect, it's going to be close enough. And then what we can do is we can go ahead and build a table or take a peek and see what this is going to look like. Now, because of how this is set up, what actually winds up happening is the graph winds up being kind of surrounded by these asymptotes. Okay, so what your graph actually winds up looking like is like this. So it gets closer and closer and closer here, and then it's going to loop around and get closer and closer and closer here. And then the same thing on this side. Really close, loops around, really close. Okay? And they follow these asymptotes all along, but never actually touch. Okay? So that's your first look at a slant asymptote. They're really not too bad. You just have to remember how to do that long division. Okay, so occurrences of lines of asymptotes for rational functions. So let's just go over all of them here. Vertical asymptotes, they occur at any x values that make the denominator 0 or make the function undefined. The x-axis is the horizontal asymptote when the degree of the numerator is less than the degree in the denominator. A horizontal asymptote other than the x-axis occurs when the numerator and the denominator have the same degree. An oblique asymptote or a slant asymptote occurs when the degree of the numerator is greater than the degree in the denominator. So there can only be one horizontal asymptote or one oblique asymptote, but never both. Can't have both at the same time. An asymptote is not part of the graph of the function. That's why we do it in dotted and we kind of sketch it in. It shouldn't actually be a line. When you have a crossing asymptote, the graph of the rational function never crosses a vertical asymptote. Okay, the graph never crosses a vertical asymptote. I should have an R in there. The graph of a rational function might cross a horizontal asymptote, but doesn't necessarily. So we will see some occurrences where it does cross a horizontal. To graph a rational function where p of x and q of x have no common factors other than the constants, we find any real zeros of the denominator, we determine the domain of the function, and we sketch the vertical asymptotes. Then we find the horizontal asymptote or the oblique asymptote, if there is one, and we sketch that. Then we find any zeros of the function. The zeros are found by determining the zeros of the numerator, okay, when the numerator equals 0. These are the first coordinates of the x-intercepts of the graph. Then we set the function equal to 0, or we plug in 0 for x, and that gives us the y-intercept. Okay, so set the equation equal to 0, or the numerator equal to 0 to find the x-intercepts, plug in 0 for x to find the y. And then we find other function values to determine the general shape, and then we draw the graph. So these do take a little time, and you do have to be able to do them by hand. You will not be allowed to use your calculator to do these ones out. Okay? Okay. So here's our first one. So we've got some things to figure out, right? Okay, so here's our function. So we're going to start by finding the zeros of the denominator. And the way we do that is by taking the denominator and setting it equal to 0 and solving it out. Okay? So generally we like to try and factor. So we'll see if it's factorable. 3xx multiplies to be 6, adds to be 7. So let's try 2 and 3. 3x, 9x, 2x. I have a positive 9 and a negative 2. That would give me a 7. So I find that my zeros are 2/3 and negative 3. Okay, so that means my domain is going to be from negative infinity to negative 3, and then negative 3 to 2/3, and then 2/3 to infinity. All right. So since neither 0 of the denominator is a 0 of the numerator, the graph is going to have a vertical asymptote at x equals 2/3 and x equals -3. So that's some important information, right? We just found some important information that we're going to use when we're graphing. Okay, vertical asymptotes. That's where the function is undefined. Okay, so that was step 1. Step 2 is because the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at y equals 0. Okay, so more important information, right? We're going to use that as well. Third step, we want to find the zeros of the numerator. So we're going to take our numerator and we'll set it equal to 0. We get x equals -3/2. Okay. So I know that -3/2 0 is the x-intercept. All right, I set the y equal to 0. I set the function equal to 0. That's going to give us our x-intercept. Step 4, we find f of 0. We get 3 -6, which is -1/2. So what that tells me is the point 0, -1/2 is the y-intercept. Okay, so I've got x-intercept, I have y-intercept, so we've got some good information. We've got vertical asymptote, we've got horizontal asymptote. And then what we do is we find other values around the ones we have found that are going to give us some shape for this graph. Okay. So we'll try -4.5, -3.25. And you do want to use decimal values because these kind of can get tricky in little squeezy spots. Okay. I'm just kind of throwing together some values that I think might give me some nice shape around my asymptotes and my intercepts. And I can very quickly gather these just by looking at the table. I'm not asking you to reinvent the wheel here. Use the tools you're given. Okay, so now that I have all those values, what I'm able to do is I'm able to go through and I'm able to plot all of this important information. Okay. All right, so first things first, we need to get in our asymptotes. That's where we always start. Okay, so we know we have a, let's see here, vertical asymptotes at 2/3 and -3. So here's -3, that one's easy to find. And then 2/3 is going to be like somewhere in here. I have a horizontal at y equals 0. So that's along my x-axis. Okay, so now let's put in my zeros. I found my x-intercept to be at -3/2, 0. So my x-intercept -3/2, 0, about here. My y-intercept at 0, -1/2. Okay. And then I go to the points that were sketched around. So I'm going to use these points to kind of guide me. Negative 4.5 was at negative 0.26. So it's like here, okay? And since that one point, I can guide myself. I know that this is going to go up and get close to that, but never touch it. And I know that it's going to go down. It's going to guide it, right? Here, did I choose negative 2? I'm pretty sure I did. Negative 2.5, I got 4.2. So negative 2.5, I got 4.2. It's like somewhere here. This is going to kind of scoop, that's kind of ugly, scoop up. And on this side, scoop down. Okay? And then on this other side, 1.5 was about 0.5, somewhere around here. That's going to give me kind of enough to know that this is going to follow those asymptotes and go around. Okay? So we get this beautiful function. And you do have to know how to do these out by hand, so you have to be able to kind of pull them apart. Okay. So now we have a whole bunch more of these to practice in our notes. So what I'm suggesting that we do is we take a day in class and we go through and we do these together. Okay, so I'm going to stop the video here. I do want you to try one more on your own, okay? And then we will try the next one in class. All right, we'll talk to you guys tomorrow.